Welcome IGCSE students, it's great to have you along again today. We're covering standard form today, and I know that this is pretty familiar with you as you have probably done this a number of times before in your math career and science as well, but let's just have a little bit of a refresher and see if we can learn some new things today as well. So, standard form is just a way of writing big or small numbers as powers of 10. It makes them easier to read and easier to think about and understand and work with. So let me give you a few examples. We'll start off with some numbers that are large, and then we'll do some that are smaller and just see if we can understand how this works. So with standard form, you always start off with one number in the units place. Then everything else will be on the other side of the decimal point. In this case we don't have anything because there's only one non-zero digit here. So we will say this is 7 times 10 to the power of, now you know 10 to the power of 1 is timesing by 10, so that would be there. 10 to the power of 2, 10 to the power of 3, 10 to the power of 4. So this is 10 to the power of 4. What you do with these is basically count all the digits up until the one that you've got at the front here. So 1, 2, 3, 4. So it's 7 times 10 to the power of 4. But that makes sense because you know that 10 to the power of 4 is 10,000. So 7 times 10,000 is 70,000. Let's try the same one here. We've got 12,300,000. So one number, then decimal point. Make sure you do that. Don't have 1, 2, 3. Point something. It's 1.23, and you go all the way until you get to you've used up all your non-zero digits, times 10 to the power of 1, 2, 3, 4, 5, 6, 7. And you know that 10 to the power of 6 is a million, which would take us to here. 10 to the power of take us to there, sorry, and 10 to the power of 7 will take us into the 10 millions place, and 1 times 10 million is 10 million, so 1.2 times 10 million is 12 million, so we're good. This is making sense. Let's try this last one here. 7 decimal point, and then you go all the way along till you've run out or used up all of your non-zero digits, times 10 to the power of 1, 2, 3, 4. Does this make sense? Well, yes, again, it's very similar to the 70,000 we did here. This is 70,530. So, yes, that makes sense. We, again, start with our first non-zero digit. That is in our units place. Everything else is after the decimal point. In this case, there are no other non-zero digits. And then we go times 10 to the power of. Now, anything in this place is going to be 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 4, so it's 10 to the negative 4. This one here, this will be 2, then 0.31, so this one goes into the units, everything else after it, in the after the decimal point, times 10 to the power of, and we count tenths, hundredths, it's in the hundredths place, so it's 10 to the power of negative 2, 1, 2. Final one, 1.01 times 10 to the power of, tenths, hundredths in the thousandths place, so to the minus 3, 1, 2, 3, and we are done. Okay, so some of the problems in the exercise will require us to work with numbers in standard form, and I know you can do this in your calculator, but it's also good to be able to do it in your head or in a written way. So we've got 3 times 10 to the power of 3, and we're multiplying that by 5 times 10 to the power of negative 5. And another way of thinking about this is 3 times 5 times 10 to the power of 3 times 10 to the power of negative 5. So we have 15 times 10, and we use our index rules when we're multiplying. We add the indices to the power of negative 2. And so we can say, well, that is equal to 1.5 times 10 to the negative 1. They are the same, and we wanted to keep our answer in standard form, so that's why I've left it here and moved from here to here. Okay, let's have a look at this one here. 6, so we're going to use the same logic here. We're going to say 6 divided by 3 times 10 to the power of 3 divided by 10 to the power of 4. This will be equal to 2 times 10 to the power, we use our index laws, of negative 1. And so this will be equal to, well, we're okay there. We can leave it at that point. 2 times 10 to the power of negative 1. This one here, we are going to add. And you notice that they're both times 10 to the power of 3. So it's simply going to be 8.1 plus 1.2. So this will be 9.3 times 10 to the power of 3. That's nice and easy. So sometimes they get a bit more difficult. We've got 10 to the power of 3 here, 10 to the power of minus 1. So this is just simply 7300 plus 0.82, and then we can add them together. So it's just simply going to be 7300.82 or 7.30082 times 10 to the power of 3. This one here, 8.7 times 10 to the negative 5 minus 1.5 times 10 to the negative 5. Another easy one, both 10 to the negative 5. So 8.7 minus 1.5 is 7.2, and simply times 10 to the power of negative 5. Well, I hope this gives you enough information to start the exercise on your own, and hopefully you won't have too many difficulties with it. But as always, if you do, make sure you ask. I'm your teacher still, even though we're not in the same room. I still want to help you, so ask your questions, flick me an email, and I'll be able to produce another video for you or send you a written working. Take care.